minus 4, 2x plus 7 to the third minus x minus 4 squared times 3 times 2x plus 7 squared times 2. Everything divided by 2x plus 7, everything to the 6th power. So before, in order for us to, thank you. In order for us to, when you come to my office hours, in order for us to make headway and not start from scratch, always watch the videos as many times as you can so you have the basics. Because if I start from the very beginning, let's factor out x from such and such, then you're not gonna get the most out of the office hours or the meeting with me. Is that clear? Okay, perfect. So I'm looking at this expression. It's a rational expression. It has how many terms at the top? 2. Obviously, this is fine, but I really don't like these two factors thrown in there, one in the middle and one at the end. So my first thought is to clean it up. So in order to clean it up, I will rewrite the first term, and I will multiply 2 and 3 because I can rearrange. Remember, multiplication is commutative and associative. So I will put the 6 in front, and then I have x minus 4 squared and then 2x plus 7 squared. They are both squared. Did I copy that correctly? Squared, squared? Very good. Let me draw your attention to something very important. What I don't want to see, it would make me cry, if somebody would cross this from here with this from here, or this from here with this from here. That would make me cry because this is a factor inside a term, this is a factor inside a term, and this is a factor. You cannot take a piece from a term and simplify it with a factor. So please remember that. That's not allowed. All we can do is look at the top and say, yes, there is something I can factor out. And what is that something that I can factor out? Yes, Ryan?
X minus 4 and 2x plus 7.
I said Ryan, right?
Yeah.
I'm sorry.
Oh, well, x minus 4, 2x plus 7.
So first of all, I'm looking at numbers. 2 and 6. That's my first step. So 2 and 6, they have what in common? 2. Then I move on to x minus 4 and x minus 4. So this one has power 1, and this one has power 2. Now I can move on and decide x minus 4 is a common factor. Which power will I pick? Perfect. The smallest of the two between 1 and 2. Awesome. Now I move on to the next one. I see there is another common factor, which is 2x plus 7. Power 3, power 2. Which one?
2.
Very good. Now I open brackets. In here, I have to have something that is left over from the first term, then minus something that is left over from the second term. Good. So 2 is out, x minus 4 is out. 2 of the 3 are out. So what is left from the first term? That's it. I reach this stage in which I have to copy minus. That's where I'm at. From 6, I took out a 2. What is left? Good. X minus 4. From 2, I took out 1. What is left? And I have to use parentheses. These are all gone because there were 2 again at the beginning, and now 2 are out. Any questions so far? Okay, so now I can do this because I'm simplifying a factor from the top with a factor from the bottom, which I could have not done before, factoring. So I copy the 2 and then x minus 4, and now I have to perform the operations inside. In order not to write it twice, I'm going to say 2x minus 3x is negative x, and then 7 and plus 12, 7 plus 12 is positive 19. Over 2x plus 7, everything to the 4th. It's not super important, but I want to show you a second step, and I mean one more step here. See, this has a positive leading coefficient, power 1. That's very important. Positive leading coefficient, I cannot do anything here because anyway, power is 4. But I would like here to remove the negative leading coefficient and put it in front to x minus 4. And now please tell me what I would have to write as the last factor at the top if I took out a negative 1.
X minus.
Perfect. Both are acceptable. I don't know how my colleagues presented the final answer. I prefer this, but both are acceptable. Good. Anything else? Is there anything else you would like me to go back to? Yes, please.
From the same paper.
Yes,
Number 2.
number 2. Let's take a look at number 2. Can I borrow? No. Thanks. And number 2. 12x squared times x plus 2 minus 19x, x plus 2, and plus 5, x plus 2. Very good. Okay, ready? How many terms we see here? Yes, are they all cleaned up? They certainly are. There's nothing I can... So what is common to all these 3 terms? Nothing else but x plus 2. What is left from the first one? What is left from the middle one? And the last one is 5. Now, I have to attempt to factor what I have in brackets. This is the most difficult type of factoring. Why is it the most difficult type of factoring? Because first of all, what is it? Remember, there are only 3 types. Binomial, trinomial, polynomial. Which one is it? Right. And it's the most difficult because nothing works till the very last option. So it's in descending order, no special product, no greatest common factor, no negative leading coefficient. There is nothing I can do here. And 1 is not the leading coefficient. So therefore, it's the most difficult one. So if you use my method, you may have other methods that I, of course, accept. But if you use my method, you will do this. You will multiply 12 by positive 5, and that is 60. And you will be in search of 2 numbers whose product is 60 and whose sum is? Right, very good. I don't know if they exist or not. I haven't figured out yet. But this is, if this polynomial is factorable, I will find 2 numbers whose product is 60 and whose sum is negative 19. Now, I always start by thinking and looking at the product. If the product is positive, then I say, ooh, both numbers have to be the same, have to have the same sign. Because otherwise I can't have a positive product unless both are positive or both are negative. But then I look at the sum. Oh, their sum is negative. Therefore, both must be negative. So now I'm thinking, okay, can I find 2 numbers whose product is 60 and 2 negative numbers whose product is 60 and whose sum is negative 19? And the answer is yes. What will those numbers be? That's it. 15 and 4. Very good. 15. Negative 15 times negative 4 is positive 60. Both conditions have to be fulfilled. And their sum is negative 19. Good. But now, because the leading coefficient is not 1, I have to go back and work hard and say 12x squared minus 15x minus 4x plus 5. Now, at this stage, I broke down the negative 19x into negative 15x and negative 4. If I go back and combine them like terms, I'm making 1 step forward and 5 steps backwards. I'm not going to combine them. I want them to be 4 terms. Why? Because with 4 terms, what do I always, exactly, grouping. And that is always the easiest thing to do. From the first 2, what will you pull out? Very good. And then what is left?
4x and 5x. 5, just 5.
Good. What should I have from the other two before I even look? Now you understand how important it is to redo the problems we did in class. That is the absolute foundation of what we do in class and what we try to accomplish in this course. So what do I do next?
4x minus 5.
That's it. No doubt. But again, remember, I cannot fabricate it. It must be there. Good. So now let's figure it out. I need a sign and a factor. Sign, factor.
Factor is 1 and sign is negative.
Perfect. We don't really put the 1 in there, but I want you to see it. So then finally, these two terms have a common factor. What is the common factor that I have to pull out?
4x minus 5.
Awesome. And what is left in parentheses? From the first,
3x minus 1.
from the last, -1. Now this was just that piece, the polynomial in parentheses, in brackets. So now I can go back to my problem and finish it up. It's x plus 2, and this is factored into 4x minus 5 and 3x minus 1. And now it's finished. Any questions other than what we just had? Any questions from homework? This weekend I'm going to present, I'm going to look at what work you accomplished so far. And on Monday, I will give you an assessment of what you covered so far. So you know where you are. Okay? Everyone will get a little sticky in which I say, or is it? So one or the other. So I want to put a smiley face on the sticky. So please help. Okay, anything else for me? Yes, please, Marcus, go ahead.
So, number 1.
By number 1, we mean,
In the same here.
okay, what was the problem with number 1?
X minus 1 cubed plus 4 times x plus 2.
So what do you think was the problem here? I mean, we can do it, there was no problem, but after we did all these 3 problems on the same, from the same handout, will that be enough for you to figure out this one? Or you still think that we should do it? Whatever you decide, I'll do it.
I would.
Okay, let's do it, that's fine. Okay. So I'm looking at how many terms again? 2. The second one is acceptable. The first one, I don't like that 4 in the middle because I may mess something up. So I'm going to put 4, x minus 1 to the third, x plus 2 to the third, plus 3, x minus 1 squared, x plus 2 to the fourth. Good. 2 terms, do they have anything in common? Good. What will I pull out?
X minus 1.
Which power?
Second.
Very good. Do you all agree with x minus 1 squared? Okay, the next one.
X plus 2.
Yes?
Third.
Yes. Do you all agree with x plus 2 cubed? Yes? Very good. So now let's open brackets and see what happens. What is left from the very first term after we took out x minus 1 squared and x plus 2 cubed?
4.
Yes, 4 must be left.
X minus 1.
And in parentheses, x minus 1. I reached this stage. I'm at plus right now, plus. So what is left from the second term after I pull out the x minus 1 squared and the x plus 2 cubed?
3.
Yes, there is a 3 in there. The x minus 1 squared is completely out,
X plus 2.
and x plus 2. Is this stage clear to all of us? Is it a yes? Everyone? Yes? Yes? Danielle? Yes? Good. Okay, so I'm going to just write it here in brackets and then put it in. So this is 4x minus 4 plus 3x plus 6. So now can anyone give us the final simplified form?
plus 1
Squared. Very good.
x plus 2
Yes. Good.
x minus 4 plus 3x plus 6.
Good. So let's finish it up.
7x
Yes.
plus 2.
That's it. And that's the final simplified form, and there is nothing else we can do here. Good. Anything else? Did you discover anything new from my math lab homework or quiz or anything? Do you yes, please.
I was having some issues with the using the quadratic formula, but I worked it out at the end. I
Okay.
just wasn't sure at what point to stop because there were some that required the
Yes.
imaginary, the I.
Yes. So when you have I, when you have a square root of a negative number, you have to use the I. If you separate the solutions and you can simplify them, then you must simplify them.
Yeah, that was another thing where
Right.
it wasn't a perfect square, but it was a product of a perfect square and another number.
Right.
So you take out
You
the
have to
perfect square.
simplify the square root, yes. So for example, the square root of 9 is 3, but the square root of 18 is the square root of 9 times the square root of 2. Yes, and they will consider it wrong if you don't put 3 the square root of 2.
And so like that specific example,
Yes.
it would be plus or minus
Yes,
the
3
3 square root
square root of 2
So
over.
the 3 is still
Yes.
either. Okay.
Yes, yes, it's plus or minus 3 the square root of 2 over whatever, 2a. They may ask you to separate them with a comma. If you have any difficulty, I don't need to go back and redo the problem, just shoot me an email and say, I did this correctly, and I'll give you the point. I don't want you to waste your time redoing the same problem once you already know what you're doing. Okay?
But I mean, I guess I do have to know what terms they want. So
Right, it should be written fine and fine print, of course. But I really don't care for that. If you know what you're doing, I don't want you to, spend the time on redoing the same thing.
So you always want us to break down the square root?
Yes, my math lab is requesting it, and we have to do it as well, yeah. The square root of 6, for example, there is nothing I can do. But the square root of 18 is 9 times 2,
Yeah.
which would be the square root of 9 times the square root of 2, which
So
is 3 the square root of 2, yes.
then the way I was doing it to find if it had a perfect square in it, so I know the perfect square start 4, 9, and then what's 4,
Right.
16.
16.
So I was just dividing the number in the square root
Give me an
by that.
example so I can show you how I do it. And
Yeah,
then
I was
you
gonna
choose.
ask how you.
Yes, just give me any example
Okay.
of a square root of whatever you want. Very good point you're making.
Let me go back to where I was working on.
This is awesome. I commend you for looking at such details, and this is awesome, really. It makes me very proud.
Alright, so the last thing I have on here is square root of 177.
Very good.
So 177 is a perfect square, but I believe the square root of, I don't have my calculator. Was it,
I have a calculator here. I had doubts. 177 is not a perfect
no,
square.
so it's not, yeah,
No.
but, yeah, well, maybe that wasn't the one I was working on, but what I'm saying is there was a number that it wasn't perfectly squared, but it was the product of two that were.
Right.
And the only way I could find which two, I was just,
Do you remember the example?
I actually don't, I think I filled out one of the.
Okay, let me show you an example. Let's say. So I'm just making a number up right now. Okay, so let's say the square root of 378. And let's say I have to simplify this as much as possible. Here's how I do it. Okay, so again, this is not the only method. You don't have to use my method, but I just wanted to show you how I do it. So 378 is definitely an even number. So I will start with the first prime number, which is 2, which means 2, and then I divide 378 by 2. What do I get when I divide 378 by 2? 189. Okay, obviously this is no longer an even number, so prime number as 2, I'm kind of done with that. Okay, then I will try the prime number, which is 3. I know that this is a number that is divisible by 3. How do I know? Because when I add, this is the principle of, or divisibility by 3. When I add the digits, 9 plus 9, I get 18. If 18 is divisible by 3, then this number is divisible by 3. That's how divisibility by 3 works. So then I say this is 3. 18 divided by 3 is 6, and 9 divided by 3 is 3. Obviously, I'm not done with 3 because 6 plus 3 is 9, so I will continue with 3. 63 divided by 3 is 21. Obviously, I'm not done with 21 because it's still divisible with 3, I meant to say, because 21 I know is divisible by 3. So I know now that 378 is nothing else but 2 times 3 to the third times 7. So this is called the prime factorization of 378. 2 times 3 cubed times 7. So now when I want to put it under the square root, so the square root of 378, why am I writing 387? I'm not sure. Then I know exactly how to split it, right? So basically I have a 2, 3, 9, and 7. So only the 9 will be a perfect square. So 2 times 3 is 6, and 6 times 7 is 42. So this is basically 9 times 42. And there's nothing else I can do other than write the square root of 9 times the square root of 42, which will be 3, the square root of 42.
Okay.
It's a different way.
Yeah, I like how you did it. I just wanted.
And I do start from the first prime number, which is 2, then I go to 3, then the next one would be 5, then the next one would be 7, then the next one would be 11. So I use only prime numbers. Okay? So you wanted to say something, forgive me, I think I interrupted you.
Yeah, so the way I did it, I just want to mention it in case you can tell me, oh, don't do that, it won't work in certain cases.
Correct.
So, square root of 378, right? So, like, I know 2 times 2 is 4, and then I know 3 times 3 is 9, and then 4 times 4 is 16. So I divided 378 by 4.
Which doesn't work.
Which doesn't work. And then I divided 378 by 9, and I got 42. So
Okay.
that's how
That's fine too.
that works.
I just wanted to show you how,
If I needed to show my work.
if it takes shorter, if your method takes shorter, I'm fine with it. Once you find the numbers, I'm not really interested in how you found them. Whatever works for you, it's fine. Sure, my pleasure. Anything else? Other questions here? Is there anything else? Is there anything else that you worked on? Anything else that you... Yes, Marcus, you had something?
I was just going to ask you, where did the 42 come from?
So this is 2 times 3 times 9 times 7. This is 6 times 7, 42, and then 9 in front. Because these 2, 3, 7 are not perfect squares. Yeah, so that's why I separated 9 from the rest. Very good. Anything else? Anything else? Okay, so let's go back and finish up this chapter and start chapter 2. So 1.7, we were talking about inequalities. We looked at linear and we looked at compound inequalities. Now I would like to look at a couple of examples with absolute value inequalities. Last one. Absolute value inequalities. They are of 2 types. This is type 1. As an example, and this is type 2. I don't have to have the equal symbol. I can only have less than or greater than. I don't have to have 3. This is just a simple example. I don't have to have x. I can have an expression with x. But this is the first example that I would like to present so I can refresh your memory on how to solve absolute value inequalities, and then we'll look at more sophisticated examples. Okay, so this first one, I'm going to tell you what it tells me. This first inequality is asking me to do this. First of all, let's establish one thing. What do we mean by the absolute value of x?
Distance from 0.
Awesome. The absolute value of x is the distance between x and 0. Correct? Good. So what the first one is telling me is this. Find all numbers x such that the distance between those numbers x and 0 is 3 units or less. One more time. Find all numbers x whose distance from 0, the distance between x and 0, is a number that is 3 units or less. That's what it tells me. So, what does that mean? Where will I find those numbers? So I'm going to draw the number line. It's also called a real line. I will present 0 in the middle. And you will tell me where will I find those numbers, x, with distance from 0, 3 units, or less. Where will I find them?
Between 0 and 3.
3 units or less, yes. Perfect. Thank you. Between -3 and +3. So the solution to this inequality is this. How do we write it? So the absolute value of x less than or equal to 3 means -3 less than or equal to x less than or equal to 3. In interval notation is exactly what we see. And I like to write x is a number in the interval -3, 3. The reason why I like to write this is because if these were parentheses and I wouldn't write this, I would say maybe it's an ordered pair, x comma y, even to avoid confusion. Yes, please.
So would either of those work as an answer?
Say it again.
Either of those work as an answer?
Yes, but the answer will be requested or has to be presented in interval notation. Yeah. That's why I graphed it. That's why I showed the translation, and that's why I also presented the interval notation. Yes. Good question. Thank you. Okay, so here's an example. So this is a very simple situation, but here's a more sophisticated example. Let's say 2x plus 1 divided by 4 in absolute value minus 2 less than or equal to 4. And let me also put a 2 in front. And you could say, wait a minute, what does this mean? What are you doing? That was a very simple situation. It was very clear. What is this? Well, my answer would be, before you even decide what to do, is, what do you think I'm going to say? Because now you know me. Yes. Yes? Clean it up. Clean it up. Exactly. Simplify it, in other words. Good. Yes, I have to move 2 to the other side. That's the first step. Awesome. So 2x plus 1 over 4 less than or equal to 6. Perfect. What would be our next step? Of course. I have to divide by 2 to clean it up. Because remember, let's write this down. This is very important. The absolute value symbol is not a grouping symbol. It's not like parentheses in which I can distribute. Do not do that. It's not allowed. So if you're tempted to distribute the 2 in here or multiply both sides by 4 to eliminate fractions, you cannot do that. You cannot do that in the absolute value. Not allowed. Okay. So now I will ask myself this question. What could these numbers be? The whole thing. Don't even look at it. What could these these numbers be so that the distance between themselves and 0 is 3 units or less? Where will I find these numbers? Right, exactly. And now please tell me what I put inside between -3 and 3. I know you said it, but now I would like you to tell me, what do I put in there? Of course. Exactly those numbers that have to be between -3 and 3. So their absolute value is less than or equal to 3. Of course. It's a mimic of what we just did here. But this one was plain x. This one is not plain x. But the process is the same. Okay, perfect. Now this is a compound inequality, and how do I solve it? Let me draw your attention to one other thing. If I don't know how to convert this into this, I will not be able to solve. You cannot do anything here. You cannot multiply by 4, you cannot subtract 1, you cannot divide by 2, nothing. No one can touch this. This is done. There is nothing you can do there unless you are able and you understand how to convert it into this. So please remember that. Do not touch that. The only chance you have to solve it is to convert it into this. Yes?
So you never touch anything inside the absolute value sign?
Nothing.
Okay, so you just leave it as it is.
There is one property that I could apply here for the absolute value because it's a ratio,
Okay.
but there is no need for that. Okay, good. So now, in order to solve this, I have to solve this. What will be the first step? What do you think? Of course, I have to eliminate the fraction. That's the first step. Good. The left-hand side, when you multiply by 4.
-4,
Very good. Less than or equal to in the middle.
2x plus 1.
Awesome. On the right. Good. Next step, please. Awesome. Subtract 1 from all 3 sides. -13 less than or equal to 2x less than or equal to 11. Final step, please.
Divide by 2.
Of course. We divide both sides by 2 and we get -13 halves less than or equal to x less than or equal to 11 halves. The solution is right there. We are looking at it. Can you please tell me in interval notation how will I write x in the interval?
-13.
-13 halves comma 11 halves, but what symbols do I use left and right? Of course, because of the equal symbol. If I did not have the equal symbol, I would have used parentheses.
So brackets are inclusive.
Yes. Brackets are inclusive, yes.
Okay, so how would we speak that?
How do we read it?
Yes.
So x is in the interval, -13 halves to 11 halves, and both are included.
That's about 30.
Yes. Both ends of the interval are included. Yes. I need that shirt. I need that shirt. I have someone specifically in mind to give it to.
What would be the domain?
Well, this is an inequality, so this will be the domain if you want. Between -13 halves and 11 halves. Yes. Any questions? Okay, this is one type of yes. Any questions? You always remember, if you ask questions, you're helping me because I may have forgot to say something. And then I said, oh, I didn't say that. So if you have questions, please ask. Any question? No question is silly. Okay, so yes, please.
So if it was open-ended on one side, it would just be positive or negative infinity.
It's not going to happen for this type of inequality
Okay.
because this is an A and D and this type of inequality. X is greater than -13 halves and less than or equal to 11 halves.
So it's always going to be in between something.
Right. This is always a interval. It could be open or closed, but between this and this. So if I say to you, it's a very good question actually. If I say to you, I have in my pocket between $5 and $10, this is what you're going to write. 5 less than or equal to x less than or equal to 10. So it's in between, right? But the second one will have the option that you presented. Okay, here it is. So here's the second option. And we start with a very simple example that I presented a few minutes ago, but of course something different. Okay, I'm back to my real line from before, and I'm going to ask you, what does this say to you? The first one said, find x, all x values whose distance from 0, between x and 0 is less than or equal to 3. 3 or less. Can anyone tell us in plain English what this says to us? Right. So find x. Now careful, because we cannot overlap with what we did before. So now this time I want to find x whose distance from 0 is 3 units or more. One more time. 3 units or more. Not 3 units or less. So this is a more difficult situation, because this time we are looking for solutions here and here. So this converts into two separate inequalities that cannot be solved together at the same time like we just did. Can anyone give us those two inequalities? So x this one.
It's greater than or equal to 3.
Perfect. So this is this one. Now I want this one. That's it. Notice we're not changing the inequality symbol. I know you may say, oh, you changed the inequality. No, I didn't. I only thought about it. And I put the solution as I expected it to be. 3 units or more. Less than or equal to -3, or not and, greater than or equal to 3. So now how do I present the solution? Exactly what I see here. This. So the solution is x in the interval from union bracket 3 to infinity. A totally different type of inequality. Way more difficult, right? Okay, so let's look at an example. Any questions? Yes, please. It's the or. So that's how we represent mathematically the conjunction or. In other words, how do I solve that inequality, or what is the solution? I can pick any number between -infinity and -3, or I can pick a number between 3 and infinity. Anything here and anything here will solve the inequality. Let's pick. -10. -10 in absolute value is 10. 10 is greater than or equal to 3. +15. 15 in absolute value is 15, greater than or equal to 3. Good. So let's look at an example. Let's say 86 on page 203. Okay. In 86 we have 9 less than or equal to the absolute value of 4x plus 7. I don't like the way this is presented because I wanted it to be in the correct order. So I'm going to read it from here. Can anyone read from the right and tell us what to... Yes, please.
The absolute value of 4x plus 7 is greater than or equal to 1.
Good. It's completely cleaned up. I only have to make a decision. Is it the one in between? In between? Or is it the one outside? That's all I have to conclude here, and then I'll know what to do next. Notice that no one can solve this. If I don't know how to replace it, or what is the equivalent, or what it has to be transformed into, I'm not going to be able to solve. So I need to make a decision. Is it the one in between, or is it the one outside? outside. So then I have from here, this goes away, and I have to change it into two different inequalities. What is the first one?
4x plus 7 is greater than or equal to 9.
Awesome. And the second one?
4x plus 7 is less than or equal to 9.
If I write that, it's very good you said that because I want to show this. So if I write greater than or equal to 9, and then less than or equal to 9, I'm including a territory that is forbidden. Good. You really helped me with that. I would have said it anyway. So I agree with that. Good. So now these are simple linear inequalities. I have no problem. I will move 7 to the other side. I have 4x greater than or equal to 2, and then I divide by 2. So it's x greater than or equal to 1/2. That's the first inequality. Here I do the same thing. 4x less than or equal to -16, x less than or equal to -4. So I got the two inequalities, but I still have to present a solution. And the solution for this type of inequality must have what in between? Exactly. Awesome. So x in the interval. Again, if you don't like to write x in, it's fine. I'm fine with that. I recommend it. It's a habit of mine to write because it could be an open interval, and then it would look like a ordered pair. So the first one, very good. That's the first one. Awesome. From left to right. Union. That's it. So this is how we solve inequalities with absolute value. There are only two types. Once you clean it up, you will have to identify, is it in between or is it outside? When it is outside, make sure you do not include the in between because that is taken by something else. Any questions for me? Any questions? So I would like you to look at my math lab and come back and say, this was a word problem. Let's do it together. Okay? Please. Because as I said, there is no way I can present every type of problem. Okay. So we're ready now to move on to chapter 2. A lot of chapter 2 is review, but I will cover everything. So this is chapter 2. And it deals with functions and graphs. Functions and graphs. And we're going to look at some basics, first of all. Identify what a function is, read from a graph, read the domain, find the range, look at different shape of functions, and just answer several questions. Okay. I'm going to present 3 sets of bubbles. I like to call them bubbles. So this is one set of 2 bubbles, one option. Here's the second set, and here's the third set. And we will analyze these right now.